Welcome back to Math Mini Lessons. I'm Sarah, and in this video we're going to continue breaking down the third grade test. Last time we broke down the multiple choice. Now we're going to do all the constructive response, and that means open-ended problems. They go from questions 31 to 38. The first three are going to be 1-point problems, where really you're just kind of showing the answer. Very easy, whether you're writing it or typing it on a computer. And the last question is a 3-point question where you have to do multiple steps, which means the ones in the middle are your 2-point questions. And you'll have to either show your work, you may have to explain your answer, but you may have an answer and some other work to show you know how to do the problem. All right, with that, we're going to jump in because we have 8 problems to go for the rest of third grade math. All right, I'm going to read through the problem and then show the answer, and then I'll work it out. It takes Heidi 15 minutes to walk from her home to school. If she leaves her home at 8:35, what time does she get to school? And the answer for this is 8:50. Okay, so check off your work. If you have that exact answer, give yourself 1 point. If you have any other number but 8:50 a.m., then you have 0 points. So let me show you how I work this one out. I started from 8:35 a.m. and all I did was add the 15 minutes. And I know that these were my hours and these are my minutes. So I'm just adding 5 plus 5 is 10. And I carried 1. 1 plus 3 plus 1 is 5. So I have 50 minutes. And that's what you want. Remember, once it's more than 60, I go to the next hour. Luckily, that didn't happen right here. So we can leave it just like that. And my hours, it's still in the 8th hour, 8 a.m. So 8:50 a.m. All right. Now, what I mean by that, what the minutes are, like, let's say it took her 30 minutes to get to school. Like, let's say you had a case like this. Then when I add, I'm going to get 65. This isn't the time that exists. We can't have an 8:65 a.m. That would matter. I would end up taking an hour and then adding an hour over here. So I would take an hour away and then I would have to add 1 hour to the next time, which would make it 9:05. Oops. And that's super confusing, but that's all I meant by adding up the minutes. Again, if it's more than 60, we have to take away and make it into the next hour. Other ways I've seen some kids do this, and I like to think of all the different ways kids can do this. Some like to draw a clock, and I haven't drawn a clock in a while. So I draw the 12, 3, 6, 9, and then I do the ones in the middle. 1, 2, 4, 5, 7, 8, 10, and 11. And some kids may start with the 35. So the little hand starts here on the 35, and they may start adding the minutes together, 15 minutes. So I know from 7 to 8 is 5 minutes. And then from 8 to 9 is another 5 minutes. And then from 9 to 10 is another 5 minutes. So you could have done something like that where you counted to 5, 10, and 15 minutes. Both of those work. But remember, for 1-point problems, they just want to see the final answer. All right, hit pause and jot this down into your notes. Another 1-point problem, we want to write the number 3,194 in expanded form. That means we're going to stretch it all out with its place value. And when you do that, you get 3,000 plus 100 plus 90 plus 4. That's what they want to see on the bottom. If you're not sure how to do this, what I've seen some kids do is they use their place value chart. And you write down the number, and they start by just putting the numbers here at the top. So with the 3 would make 3,000. And then they look here at my 1, would just make 100. And then 9 is in the tens place, so 90. And then 4. So some kids just do that if they want to see all the different numbers. So you can do that as well. All right, hit pause and jot this down into your notes. Here's our third 1-point problem. Gail earns 32 tickets to an event, she uses all of her tickets to buy 4 prizes and the same number of tickets to buy each prize. How many tickets does Gail use to buy each prize? Well, she uses 8 tickets for every single prize. So if you had 8, awesome, give yourself a point. If you had anything else but 8, then you give yourself 0 points. So what's happening in this problem? We know that she had 32 tickets and she uses everything to buy 4 prizes. So those are 32 tickets. You can imagine she has her 4 prizes. And every single prize has the same number of tickets. So this is making me think of an equal share. So I'm thinking I can divide the 32 tickets into 4 even groups. Now again, if you know your fact families, then you know that 4 times 8 makes 32. But if you don't, I know some kids will just circle and stars it and they'll just start putting maybe like 1, 2, 1, 2. They might go 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Notice I'm putting the same number in each one. 25, 26, 27, 28, 29, 30, 31, and 32. And then they might just count how many are inside. And they had 1, 2, 3, 4, 5, 6, 7, 8. So if you don't know your fact families, you could just do something like this with circle and stars. But again, I always recommend just knowing your facts. It makes things so much faster, especially as you get older into older levels of mathematics. All right, hit pause and jot this down. All right, let's start getting into our 3-point problems. Oh no, these are 2-point problems. So I'll read it first and see how I have to do some explaining, and I can show some work for this one. Mr. Lindsay and Mrs. Abbott are comparing the size of their bulletin boards. Mr. Lindsay's board is 6 feet by 5 feet wide. Mr. Abbott's bulletin board is 7 feet long and 5 feet wide. Which board has the greater area? So that's the question I'm trying to answer. Be sure to include the area in square feet of each bulletin board. So not only do I have to say which has the greater area, I have to show that I know the area for both of them. So here's the answer I have, and this is for 2 points. So remember, I have to say which one has a greater area, and I have to give the area for both to have full credit. Miss Lindsay's board has a greater area, so I answered the first question. Miss Lindsay's board is 6 times 5, or 30 square feet, and Mr. Abbott's board is 7 times 4, or 28 square feet. 30 square feet is greater than 28 square feet, and done. So that's what makes this a 2-point response. That I did both parts and explained it in my answer. So you should have something like this. So make sure you give yourself a point if you said Miss Lindsay's board was greater, and give yourself a point if you gave the areas for both, the 30 and the 28. If you didn't give the areas for both, then you may have to take a point away from there. Here's another 2-point question. A list of fractions is shown below. 2/8, 1/3, 3/4, 2/6. Which 2 fractions in the list are equivalent? Be sure to include what you know about fractions in your answer. So again, I get 1 point for doing this, for finding which 2 are equivalent, and I get another point for being able to say how I know. All right, so here's the answer I have. 1/3 and 2/6 are equivalent. I used a table to find a common denominator. I'm going to make the table in front of you so you can see it. To find a common denominator for 8, 3, 4, and 6. The common denominator was 24. So what I did was, I literally just made these tables. A lot of times I do the work and then I erase it before I record it, so that I make sure that I can explain it really, really well. So I start off with each of these tables, and I usually start with the smallest number. And I started doing some skip counting. So 3, 6, 9, 12. And I did the same thing. Oh, so 12 could be a common denominator. And at first I was like, cool, 12 could be a common denominator. But when I started counting by 8s, nope, it skipped over. So I was like, all right, I got to keep on moving. 24 can work. I know 3s and 24 work. So I just kept on. until I got the common denominator 24. So now that I have the common denominator 24, I just skip count by numerators. So 2, 4, 6. Now I have 1, 1, 2, 3, 4, 5, 6, 7, 8. And I'll go by 3s, 3, 6. Oops, leave that out. 3, 6, 9, 12, 15, 18, and 2, 4, 6, and 8. And now it was really easy for me to compare them and to find the two that were the same. These two are equivalent. And my original fractions were 1/3 and 2/6. So that's the table I made to figure out the common denominator was 24. So that part, I answered the first part. But now I have to prove like what I know about fractions. That can be really hard. So I want you to pay attention to how I answered this. The common denominator was 24. So now I could compare the fractions. 1/3 and 2/6 had the same numerator, 8/24. So they are equivalent. Okay. So that's kind of how I explained through it. I could have given a little bit more maybe by saying when the numerators are the same and the denominators are the same, they are equivalent. So maybe I could even add that part in. But this would be enough to give me my 2 points. A lot of kids will probably answer the first part and really struggle to say, well, how do I know that the two fractions are the same size? You need to be able to name that I can only compare them when my when my denominators are the same. And then I can compare my numerators. If the numerators are the same too, then I know they're equal. If the numerators are different, then I know one is greater or smaller than the other. All right, so hit pause, look at your answer, and give yourself 0, 1, or 2 points. A librarian is ordering new books. The cost of one book of each type is shown below. So it's on that table. The librarian orders 20 picture books, 30 chapter books, 10 reference books. What is the total cost of all the books that she orders? And I have to show your work. So you get a point for the answer, get a point for getting this right answer, and you're going to get another point for being able to show your work how you got that answer. And the answer here is 360. So give yourself a point if you got 360. Now you have to show how you're going to get that 360. Okay, so I know with the picture books, they are $5. So she orders 20 picture books, so 20 times 5 plus 30 chapter books, so that's 30. And each book is $6. And I have 10 reference books for $8. So this is what I have. So now I can add them up. 100, 30 times 6. So 3 times 6 is 18 plus a 0. And 10 times 8 is 80. Now I just got to add these up. I'm going to stack them. And I get $360. All right, so you can jot this one down into your notes as well. Give yourself 1 point if you got 360 and another point if your work shows how you got the 360. Here's our last. Nope, I think this is the last 2-point problem. Ms. Thompson buys 3 packs of clay for a project. Each pack weighs 25 pounds. An equal amount of clay is given to all 5 groups of students. How many pounds does each kid get? Well, there's a lot of stuff happening in this problem. So you are going to get a point. So you get 1 point for showing your work and 1 point for answering that final question of how many pounds of clay, which is 15 pounds. So how are we going to get there? So give yourself 1 point if you got the 15 pounds. All right, so she has 3 packs of clay, and each of them has 25 pounds. So you could have done 3 times 25 is 75 pounds of clay. So that's the first thing. You want to see how you're going to get to 75, whether you're doing a drawing or you're using a number sentence. They need to see that. And then she's going to give every single group of students, an equal amount is given to 5 groups. So I'm giving it, so I'm sharing by 5. So how am I going to get this part? I'm going to do actually long division here. and 5 goes into 7 one time. 25. 5 goes into 25 5 times. 25, and I get 0. So each group gets 15 pounds. Okay, and that's my final answer. Now, another thing some kids could have done is just by reading the problem, a lot of times they would have started by just figuring out, like, I knew I was going to do 3 times 5, and then after that I knew I was going to share it with 5 groups. So that could have been something else you had written down in here. Well, altogether you had to somehow show that you're multiplying 3 times, not 5, 3 times 25 to get 75, and then you're dividing that product by 5 when you're sharing. So those 2 things, if you did both, you will get a point for both. All right, here's the last one, 3 points. There's a whole bunch of different combinations that can come in. We have to answer, it says explain your answer for 2 parts, and we're going to show some work. So we're going to start by reading through. There's a lot of detail. The list below shows the distances between Manny's home, school, and the park. So between his home and school is 3/4 of a mile. Between home and the park is 3/8 of a mile. So I'm kind of going to imagine it like, here's his house, here's school, here's the park. From his house to the park is 3/8. So the first part says is, does he live closer to the school or to the park? So the shorter the distance, the closer he is. So I need to compare these 2 fractions. So let's compare them. I am going to do for this one, you know what, let's do, here's 3/8, here's 3/4. I start with a smaller fraction, and boom, I get a equal denominator right off the bat, 8 and 8. So I'm going to skip count by 3s, 3, 6. So now I can compare these 2, 3/8 and 3/6. And I know that 3/8 is smaller than 6/8. So he has to live closer. So think about it this way. This is a longer walk because this number is bigger than this one. So he's closer to the park. So that's what I'm going to write. Manny lives closer to the park because 3/8 is smaller than 3/4. Actually, I want to put instead of 3/4, I'm going to put the 6/8. Okay, and then I'm going to say, explain my answer. I can compare them because I want us to be able to say that I know this is true because they're the same. They have the same denominator, but not the same numerator. When the denominator is the same, I can compare the numerators. 3/4 is the same as 6/8, and 3/8 is smaller than 6/8. All right, so done. So really simple sentences. Honestly, I try to write very simply when I'm explaining my math thoughts because it can get really complicated, and the more complicated we make it, sometimes the harder it is to understand. So you'll give yourself a point there for that and be able to show your work. And then the second question is, the distance between Pilar's home and the same park is 5/8. Who lives closer to the park? So now Pilar is 5/8, and we know Manny, because we just did it, is 3/8. So who lives closer? Manny again, because 3/8 is still smaller than 5/8. So Manny is closer because 3/8 is less than 5/8. The denominator, I'm going to shorten that up, are the same. So I compared the numerator. And Manny's distance was smaller. So that's a very valid reason. Now there are all kinds, again, different combinations you can use for this. Like I've seen some kids go and they argue, well, since my numerators are the same in the first one, 3 and 3, I know that this one has to be bigger because the denominator is smaller. Like the smaller the denominator, the bigger the pieces. So I know some kids have said that for the first answer and they didn't make the denominators the same. You can do that too. What they want to say is that you have a valid way of just comparing fractions that makes sense, and you're using what you know about numerators and denominators to do so. So you have to be able to really explain your thinking to get the full points, and somehow your work has to show that. And here you can kind of see the work I did to compare my fractions in the beginning. And on the bottom one, I didn't have to do any work because my denominators are already the same, but I'm explaining why I can compare them. So I'm going to hit pause here and go back into your work and give yourself either 0, 1, or 2 points on how you answered both questions and if your work also justifies it. And that's it for the constructive response. That's the last big question on the state test. So I hope you found this really helpful. And if you add up all your points, all the multiple choice and all the constructive response points, you can see how well you're doing on this state test. Like, would you be able to pass if this test was today? And this is my really general conversion chart, is how we decide if you have a 1, 2, 3, or 4. So it's just very general. And in order to get a level 3, you need a 30 points. So all your multiple choice questions are just 1 point, and all the constructive responses were either 1, 2, or 3 points. You would add all of those up to figure out how many points you would have. And if you have 30, then you would have a level 3. If you have, and you can just see here, out of all 44 points, you can use this to figure out roughly what your score would be. Now on the state test, obviously you're not going to know at the end, but you want to kind of aim the same way. You want to feel really comfortable with a little bit more than half the state test. And I'm pretty confident that if you're watching these videos, if these strategies make sense to you, then you'll be fine. But if you're having any trouble with any of these strategies or any of these types of questions, just let me know in the comments. I'm really happy to help. I want all of you to do well on this state test. That's what I'm here to do. So I hope that you found this helpful. I will see you next year in 4th grade, where I'll have more videos for you. Until then, be well, Math Marbles. Bye.